My name is Minjeong Rachel from the island of Guam, representing St. John's School. Today I'll be explaining my science fair project to you all. Hope you enjoy! My science fair project was Learning from Our Past, Application of the Physics Behind Slingstones. So starting off with some background information of slingstones. Slingstones are stones of various sizes, sharpened at both ends and hurled from a sling with deadly force. And this was formalized after AD 1000. The slingstones are not known elsewhere in the Pacific Ocean except the island of Guam. In Chamorro, it is called Acho Atupat, and Chamorro is the national language of Guam. Guam is in fact the world's only political entity that features the slingstone on its seal and flag as shown below. So my research question for this project was, according to the physics, in particular projectile motion, destructive force, and accuracy of slingstones, are slingstones the most effective weapon? The objective of this experiment was to determine if slingstones are the most effective weapon compared with limestones and riverstones, which are also very important stones on Guam. So my hypothesis was, if the stones are all calculated in 3 different physical aspects, that the slingstones will be the most effective weapon compared to riverstones and limestones because of its unique and consistent shape. So the materials used for this experiment were slingstones, limestones, and riverstones, and an electronic device and a logger pro needed for projectile motion, an archery board needed for accuracy, and cardboard needed for destructive force. And the shooter on the right was a self-made device by me and the help of my father, which I will explain further later. So as you can see, these are 2 pictures of me picking up stones, as the stones are very common on beaches. So the materials for the shooter that I self-made with my father was rectangular pipe metal, L-shaped metal, big nails, hexagon bolt and nut, leather, and a rubber band. My variables for this project. The independent variable was the type of stone and the shooter. The dependent variable was velocity, force, and accuracy, and my control variables were the mass of the stones and the distance pulled upon firing. Now I will go on to methods. First, I will explain the methods for my shooter, as it is a very important element to conduct my experiment. So first, I took 10 L-shaped metals and created a rectangular prism structure, as shown below. Then I prepared 4 rectangular pipe metals. I vertically attached 2 rectangular pipe metals and attached 2 rectangular pipe metals horizontally to the rectangular prism structure by using 8 hexagon bolts and nuts. Then I secured the balance of the shooter, especially when pulled upon firing, by hammering 2 nails on the horizontal rectangular pipe metal, 1 front and 1 back. I combined the piece of leather to the rubber band, and I attached this rubber band to the 2 vertical rectangular pipe metals as shown. And this was how my final product looked like, and I used the shooter to conduct all of my experiments. Now I will give my methods for projectile motion. First, I prepared all materials, specifically the shooter and the logger pro. Then I placed a stone on the leather to shoot. I pulled back with the same distance, and I let go of the rubber band. And I filmed a video of the stone flight using an electronic device, and I repeated steps 1 to 5 for each stone 6 times, having a total of 18 trials. Then I imported the videos I filmed to the Logger Pro. Afterwards, I recorded my results. Continuing on with my methods for destructive force. So first I prepared all materials, specifically the cardboard as you can see, with the side view and the front view, and the measurements shown below. Then I placed a stone on the leather to shoot. I pulled back with the same distance, and I let go of the rubber band. Then I recorded results of how many cardboard the stone went through. Then I repeated steps 1 to 5 for each stone 6 times, having a total of 18 trials once again. Last but not least, methods for accuracy. I prepared all materials, and for accuracy I needed an archery board. Then I placed a stone on the leather to shoot, pulled back with the same distance, let go of the rubber band, and I recorded results of which color the stone hit. As seen below, number 1 represents periphery of the circle, and number 6 representing center yellow area. Basically meaning that higher the number, the more accurate the stone was, and I will explain this later in the results. Then I repeated steps 1 to 5 for each stone 6 times, once again having a total of 18 trials. Now, going on with my results. So for the projectile motion, the maximum velocities for each stone were recorded using the video analysis tool on Logger Pro. So this is the table of my velocities for slingstone, limestones, and riverstones. And as you can see by looking at this table, that the velocity for the slingstones were much higher compared to the limestone and the riverstones. For a better picture, I have provided a graph. And once again, you can see that the slingstone bar graph is much higher than the limestone and the riverstone. And the limestone and the riverstones were pretty similar to each other in terms of velocity. This is a picture of my mathematical formulas to prove more on my projectile motion. So I used this formula and plugged in the numbers of the distance and the initial velocity to find the degree angle. And how I got this formula here was I derived it from the kinematic formula and I solved it to get it to here. For the slingstones, it was close to 60 degrees, and 60 degrees meaning the most ideal situation in which the stone was shot. On the other hand, for the limestones and the riverstones, it was about 10 to 15 degrees. This supports my argument on how the slingstones were the most ideal in projectile motion. For destructive force, as I mentioned earlier, the number of cardboards one stone could pierce through was recorded. This is the table. The slingstones range from about 2 to 4 cardboards, limestones range from 0 to 1, and riverstones ranged also from 0 to 1. This is a picture of the slingstone of the cardboards pierced through, and as you can see, there are 3 cardboards the slingstones pierced through, representing how strong the stones are. This is my graph for destructive force, and as you can see that the slingstone is much higher compared to the limestone and the riverstones. And the riverstones were in fact stronger than the limestones. I also had quantitative data for destructive force, and I solved this by using Newton's second law of motion. So I used F equals m times a, mass times acceleration, and acceleration is velocity divided by time. So earlier in the projectile motion, I found the velocity, and I have mentioned that the velocity was highest for the slingstones, and the time was on average 3 seconds based on the videos I filmed. Therefore, if the velocity is higher, then the acceleration is higher. And when I plug it back in into the F equals m times a, the mass was constant. It was a control variable, and so the force was higher for slingstones. Accuracy. The scores on the target board were tallied for each stone. Higher score represented better accuracy. This is the table. Slingstone ranged from 4 to 6, limestones range from 1 to 5, and riverstones range from 1 to 4. These are some videos for my riverstone. So as you can see, the riverstone hit right there, around between the black and the yellow area. Now for limestones, it hit right there in the black area. And for the slingstones, it hit right in the center area, number 6. And as you can see, when the slingstone flew, it left a mark on the board, also proving that it is very strong compared to the other stones. This is the graph for my accuracy. Slingstones were the most accurate, and the limestones and riverstones were pretty similar in terms of accuracy. So for my conclusion, according to the results, slingstones are the most effective weapon in terms of projectile motion, destructive force, and accuracy, and therefore the hypothesis was supported. So for future work and improvements, I want to try to compare my data with more stones other than the limestones and the riverstones to find my data more accurate, although I have proven my hypothesis correct. In the future, I want to see how can the shape of slingstones be incorporated into a 21st century design. I would like to investigate more on that in the future. This is the website I used for my background information. And I'd like to thank Mr. Alvarez for guiding me through the process and helping me find materials. I also would really like to thank Sling Guam for the access to the slingstones I used to conduct the experiment and the different photos I used during this presentation. Thank you so much for listening. Thank you for watching this video. I hope you learned a lot about my science fair project, but also the culture of Guam. Thank you and hope to see you again.